I can also measure what is the temperature generated by the friction of the tire and the road. The quantity which exists independently and does not depend on any other physical quantities are known as fundamental quantities. And for this particular derived system of units, you can see that here it is meter per second. Length is a form of measurement to measure how long or how far a certain object or place or thing is. Hey all, I'm Hari Krishnan from the Department of Physics, Vidhyaashram PU College, the Temple of Excellence. And here we are going to start our chapter by learning about units and measurements. We will learn how to measure something and how to mark each unit. Meters, kilometers, kilograms, grams, milligrams, everything will be learned in this particular chapter. Why there are units like that and why we choose certain units and why we don't measure certain things like differently. So firstly, physical quantities. So what exactly is a physical quantity? Is it just physical quantity or are there any emotional or spiritual quantities? So according to physics, physical quantities are any quantities that can be measured. I have a dear friend Vishnu and he's going through an emotionally tough time because he just became a dad. So things are a bit hard on him. So when I ask him, how emotionally wrecked are you? How emotionally broken are you? He'll say a lot. And I cannot actually say that, is it 1 kilo broken or maybe 10 pieces broken? No, right? I cannot actually evaluate what is the emotional pain of an individual. That cannot be physically measured. I can measure what is his height. I can measure what is his weight. I can measure how fastly or how frequently he closes or blinks his eyes. But I cannot measure what is my friend's emotional pain. So there are several things we cannot measure and there are several things which we can measure, and those particular quantities which we can measure and give a unit is known as a physical quantity. For example, if this is my cute friend Vishnu, let's say this is Vishnu, then I can measure his length. I can measure how tall he is. And if I place a weighing scale here, I can measure how heavy he is. I can measure how heavy he is. His weight I can measure. His length I can measure. I can even measure how thick he is. That is, how fat or how thin he is. So all these quantities can be measured. I can measure the length, breadth, height, weight. All those quantities which I can measure are known as physical quantities, and they include time, mass, temperature, area, velocity, temperature. Everything can be measured, but there are some things which cannot be measured, just like the emotional pain of an individual or how heavy a heart is. I cannot measure, but I can actually measure how tall a person is. So that is the difference between a physical quantity and certain other quantities in life. So to make it more clear, we can clearly say that if I am driving a car which has a certain mass, that is, it has a certain weight to it, it is traveling at a particular velocity or speed and it reaches a particular destination in a given amount of time. In doing so, it created a lot of heat in its tires. So I can say that I can measure its speed, I can measure its acceleration, I can measure the time taken for that particular car to reach a certain place. I can also measure what is the temperature generated by the friction of the tire and the road. So these are quantities which I can measure, and those particular quantities are known as physical quantities. In these physical quantities, there is a category known as fundamental quantities. These physical quantities are made up of 7 basic fundamental quantities. These fundamental quantities stand alone. That is, they don't require anyone's support to exist. So, the quantity which exists independently and does not depend on any other physical quantities are known as fundamental quantities, or they can be also known as basic quantities. They can be also called as basic quantities. But there is a certain category of physical quantities which are dependent on these fundamental basic quantities. That particular quantities are known as derived quantities or derived units. That is because they are obtained from or obtained using the fundamental quantities. With various combinations and combining them together, we will get derived quantities. For example, if I say my friend, again Vishnu, is driving his car at 25 meter per second, that is, he's driving a car at 25 meter per second square acceleration or 25 meter per second velocity, I can say that that particular acceleration or velocity is a derived quantity. That is because I'll tell you what are the basic quantities, but let's say length, or in this particular case time and length, are physical quantities which are considered to be basic quantities. That is, these are basic fundamental quantities. Now I just told you that my friend Vishnu was traveling with a velocity or with an acceleration of certain value, which means that velocity is equal to, or V is equal to, displacement divided by time, which means displacement is nothing but length measured in the horizontal direction or vertical direction. It does not matter. What matters is that displacement is nothing but length being measured, and it is divided by time. So length covered per unit time is known as velocity, or displacement per unit time is known as velocity, which means we used two fundamental factors, that is, we used time t and length L in order to obtain a new form, that is velocity. So this particular term, that is this particular term velocity, is a derived quantity, and it is derived from the fundamental quantities which are time and length, that is used here. There are a total of 7 fundamental quantities, of which we just used 2 in order to derive velocity. Now he's traveling with 25 meter per second square acceleration. Then I can say that the acceleration A is equal to V by T, or simply A is equal to d square x by dt square. My point is that this particular acceleration is again derived from velocity, which means that acceleration is also indirectly derived from this particular basic quantities. So we can say that all these derived quantities such as velocity, acceleration, momentum, and all these fundamental quantities, all these other quantities which are being derived from the fundamental quantities are known as derived quantities or derived units, and the other factors which are used in the making process of this derived quantities are known as basic quantities or fundamental quantities. Imagine it like this. Atoms are the basic building blocks of every living matter. So we need atoms to make everything. So if we make a house, we can say that that particular house is a derived quantity from the fundamental elements of atoms. So just like that, we use the fundamental quantities to derive certain other quantities. I hope it is clear. The examples for derived quantities are volume, force, velocity, etc. And the examples for fundamental quantities are 7 actually, and we'll just get right to it. But before getting to that particular fundamental quantities, there is one question. How are these chosen to be the fundamental quantities? Why couldn't I measure time in terms of songs? Yes, the way again my friend says is that it will take me 5 songs. It will take me 5 songs in order to reach your house. And I'll be like, what? That is not clear at all. Is it like 5 songs each with a time duration of 5 minutes? Is it like 7 minutes? Is it like 8 minutes? I don't know what songs you're listening to. Then how can I know that you'll reach here by the time I hear 5 songs? He's saying that 2 movie times are required in order to reach Bangalore. I'm like, I don't know what type of movie you're watching. Are you watching a 90-minute movie? Are you watching a 120-minute movie? I don't know. So that is when the confusion came into place. So this lousy little comparison is actually valid because people use different states of units, or people use different types of units in order to measure certain things. In certain parts of the world, there are certain units they were using, and in certain other parts of the world, certain other units were used. And this became a problem in the scientific community. Let's say he discovered a new element when he bombarded 5 kgs of uranium with 2 kgs of krypton. But the problem is that he is expressing it in terms of kilograms. But the scientist all the way across the world is expressing these quantities in terms of pounds. So he's saying that how many pounds is 1 kilogram? I don't know what is kilogram. This particular difference of units, this particular difference in measurements caused havoc. It caused confusion, unnecessary, unneeded confusion in the scientific world. So that is why a system international was found. That is a standard system of units that is applied across all scientific platforms so that scientific quantities or measurements can be made across the world or across the globe in a similar fashion. So there is no confusion. If I take 1 kg of banana here, it will be 1 kg of banana all the way around the world. So kg and kg are same. So for that purpose, to have uniformity, to have unity, just like you wear uniforms at school, we also adopted a system known as System International. It was done by the French, and that particular System International, the System International units are known as SI units. That is why when we make a measurement in physics, we say according to SI unit, write the SI unit. That is System International units. Unified units, one metric of unit for everyone around the globe. For every scientist, for everyone making the measurements. In a scientific platform, you need to make the values in SI units. And then I explained the importance of SI units to my dear friend, and he now says that it is almost 5 kilometers from his house to my house. So in order to express the units, we have all the fundamental quantities such as time, length, mass, all that needs a unit to express itself. That is, a unit measurement is required to measure how much that particular quantity is contained in a certain substance. So in order to measure these fundamental quantities, physical quantities, we needed a unified unit. That particular unit system, which was accepted by everyone, is now known as Internationally Accepted Standard Reference, or simply System International of Units, SI units. So we call it as SI unit because it is System International. This is known as SI units. There are two particular physical quantities. One is basic quantities or fundamental quantities, and the other one is derived quantities. The basic quantities contain such as length, time, mass, and the units are meter, seconds, kilograms, and there are derived units which are derived from these fundamental quantities such as force, velocity, energy, which having units such as Newton, meter per second, joules, etc. That is, if we have basic quantities such as length and time, I can say that the derived quantity is velocity, which is x by t, which is equal to velocity. So these are basic quantities and these are derived quantities, and the units used to express them are, for this particular system, it is for length, it is meter, and for time it is seconds, and for this particular derived system of units we can see that here it is meter per second. This is mass, which means we measure it in kilograms, and acceleration is measured in meter per second squared. So these are the units, and this is how derived units came into existence. Basic units are there, from those derived units also exist. This particular thing is actually existing in fundamental terms, but we can also call it as newtons using capital N. So Newton is a derived unit and meter and seconds are fundamental units. So fundamental units are meter, second, such as that from the fundamental quantities, and derived units are from fundamental units. So Newton is an example for derived units. Just now I told you the need for such a system came because people were using different modes of measuring things. Those such modes are CGS system, FPS system and MKS system. These systems are called in such a way because CGS is standing for centimeter, gram and second. That is, people used to measure length using centimeter, mass using gram system and time using seconds system. So just because people were using this system, that is CGS, length and mass and time were measured using centimeter, gram and second, the people who used this particular system were known as CGS system users. This was particularly used in different parts of the world. And then there is the FPS system, mainly used in the European part of the world. That is FPS system. They used foot, pound and second. So instead of centimeter, gram, second, some people from some parts of the world used FPS system. That is, in order to measure length, they used foot. In order to measure mass, they used pounds, and in order to measure time, they used seconds. Everyone is using seconds to measure time, at least that's a unity. So this particular system, that is the FPS system, is widely accepted because it was used by the Britishers. So since British colonized many parts of the world, this system was particularly very famous. So even now people use, they are 5 foot tall, they are 5 foot 5, they are 4 foot 8, they are 6 foot tall. So they use that particular system of measurement for length because people used to use FPS systems. And pound is nothing but a measurement of mass. 1 pound is approximately 2.2 kilograms, which means they measure pounds. 1 pound of chicken, 2 pounds of chicken, or what is the weight of an individual? I am 180 pounds or 220 pounds, like that. And finally, there is one more system, which is the MKS system or metric system. It is also known as metric system. MKS system is for meter, kilograms, and finally seconds. Meters, kilograms, second. This is the widely accepted norm around the world. Meter, kilograms, second. Meter for length, kilogram for mass, second for time. So these are the systems how people used to measure different things. So there is the CGS system, there is the MKS system, and there is the FPS system. So because of this diversity in measuring certain quantities, then the scientific world unified everything together, took different quantities, how people used to measure certain things, and they came up with the SI units, which ensures that every scientific measurement is made with unity. So if you measure the weight of an atom here or in Belgium, the weight will be expressed in the same units. So now, I've been talking about these fundamental quantities for quite a long time. So what are these fundamental quantities? The fundamental quantities are 7, and these fundamental quantities are length, mass, time, temperature, electric current, luminous intensity, and amount of substance. So again, the fundamental quantities are length, which has a unit of meter and which has a symbol m. This particular length is used to measure how long or how far a particular object is. It can be used to measure something which is sturdy. For example, we can use a scale in order to measure something, how long it is. We can also use a tape in order to measure the circumference of something. If you want to stitch a shirt, if you want to stitch a pant, they will use a tape in order to measure. So that is one form of measurement. And if you want to know how tall you are, they can use a sturdy scale in order to measure you, which has a certain length. You can actually use a scale. Length is a form of measurement to measure how long or how far a certain object or place or thing is. And its unit is meter and the symbol is m, represented by small m. And now mass. Mass is nothing but an interaction with the Higgs field. So if you want to really know the physics behind it, it is because of the interaction of matter with the Higgs field. How much it interacts, that much heavy an object will be. So mass is measured in kilograms and the symbol is kg, and time is measured in seconds, how long you take. If you say that a movie was finished in 60 minutes or 1 hour, the way you express that scientifically is that the movie was completed in 3600 seconds. That is 60 into 60. 60 seconds is 1 minute and 60 minutes is 1 hour, which means 60 into 60 will give you that particular time amount in seconds, which you have to express scientifically. So it is 3600 seconds, or simply 3.6 into 10 raised to 3 seconds. So that is how you scientifically represent that data. Now we have temperature. Normally we use Celsius in order to define temperature in the surrounding world. It is 23 degrees Celsius, it is 25 degrees Celsius, it is 42 degrees Celsius in certain part of the world. But for scientific measurements, we use a temperature scale known as Kelvin. Kelvin is a lord, actually he was a scientist, Lord Kelvin. In his tribute we are using Kelvin scale. So the lowest temperature will be 0 degrees Celsius. So 0 degrees Celsius is equal to 273 degree Kelvin, which means minus 273 Kelvin is the lowest we have measured till date, and that is close to absolute zero. Absolute zero means we cannot go even beyond that. So minus 273 Kelvin is the coldest we can go. So that is known as absolute zero. Anyways, so temperature is measured in units of Kelvin, indicated by a capital K. And finally, there is electric current, which is measured in amperes. How much current is passing through a circuit? How much current is passing through your house? All is measured in terms of ampere. And luminous intensity just tells you how bright an object is, and it is measured in terms of candela. Candela is a unit represented by CD. This is not the element cadmium from your chemistry. This is candela, which is used for measuring how bright certain objects are. Generally, it is used to measure how bright a star is, but you can also use it to measure how bright a candle is or how bright anything is, not your friend's face. Amount of substance is measured in moles. This you have seen in your chemistry. Amount of substance contained is measured in moles, and you might be familiar with Avogadro's number, which is a constant which is used for this reference. So, amount of substance, luminous intensity, electric current are the three new factors you might not be familiar with, and the units for these three factors are ampere, candela and mole. And they are represented as A for ampere, CD for candela and MOL for moles or amount of substance. Now these are fundamental quantities. There are other certain quantities which are not being discussed. That is, we only discussed things which can be measured linearly. But what if I want to measure an angle? So let's say this is 180 degrees. How do you measure them using fundamental quantities? You cannot actually. So these fundamental quantities which can be measured cannot measure the angle or angular values of certain things. That is why we invented a certain measuring system known as supplementary units. So this particular supplementary unit contains ways in order to measure angular values. There are two in nature, and they are plane angle and solid angle. Plane angle is when you use a protractor to measure something in your paper. For example, you have this particular circle here and you want to cut out, let's say, 30 degrees or 45 degrees or something. Then you can say that this particular quantity is 80 degrees or 75 degrees. Like that, if you can measure something like this, then this is known as a plane angle. That is, you're measuring in a plane, not three-dimensional but two-dimensional plane. Then you can say this is how a plane angle behaves. And plane angle can be defined as, if this is the angle theta, if the radius is r and this is the arc length, let's say it's L, then we can define theta is equal to L divided by R. So one thing you have to notice is that we are using fundamental quantities of length. This is also length, this is also length, which means this particular angle theta is dimensionless. So all the supplementary units, these two units are actually dimensionless. What are dimensions? I'll just tell you, but just remember that these are ratios. These are ratios of length, so they don't have any particular dimensions. But they do have units, and for this particular angle, the unit is radians, or we measure it in rad. So we write it as rad and the unit is radian. And this is for a plane angle. Now we also have one more angle, which is solid angle, which is used to measure in steradians, and it is SR. The symbol is SR. That is, if you have a watermelon and you scooped out a piece in the shape of a cone like this and you're giving it to your friend, then that means you're using a solid angle. Let's say you cut out a piece with a base having an area that is dA, and this particular cone shape has an angle, let's say, of d omega. Then we can say that this particular piece having a radius of r can be said to be d omega, can be expressed as dA divided by r square, or simply it is the ratio between the area of the surface and the square of its radius. Again, this is also a dimensionless quantity because it is a ratio quantity, but it does have a unit since it is a supplementary quantity and the unit is steradian. So basically speaking, if you have any quantity or any angle that you are measuring in a two-dimensional plane using your protractor or slicing of a pizza like that, then you can say that you are using a plane angle which has the unit radians or simply rads. And if you are using something to measure a three-dimensional plane, that is, you want to build a big building with a big dome like this, and you want to know what is the distance from a person standing at the floor to this particular point here. So, in order to make such measurements, if you are an architect or if you are a builder who wants to make big monuments or big dome shapes like that, then you need to have an idea about the solid angle, which is measured in steradians and the unit is expressed in SR. So these are the supplementary quantities. So we just saw what is basic fundamental quantities, what are derived quantities, what are basic units, what are derived units, what are supplementary units. Now you might have an idea of what we are dealing with. We are dealing with measurements at first. Then we are going into units, and then slowly we'll go into other topics. For example, we can just simply say that in this chapter, we will be learning about muds. You heard me right? We'll be learning about muds. Not the muds you see, but we'll be learning about measurements. We'll be learning about measurements, units, dimensions, and significant figures. So, we will be learning about muds in this chapter, and we just learned about MU. Now there is D and S remaining. We'll get to that immediately. Until then, I'll see you on very soon. I hope you have understood all about M and U, and wait till we get to D and S. So, thank you for listening to me, and I'll see you all very soon. Until that, thank you.